Hello, I am Matthew Arsamont, and I will be discussing the relevance of Figure 3 to the article titled Profilin Reduces Aggregation and Phase Separation of Huntington N-Terminal Fragments by Preferentially Binding to Soluble Monomers and Oligomers. This article has been composed by Eamon Posey, Kirsten Ruff, Tyler Harmon, Scott Crick, Eamon Lee, Mark Diamond, and Rohit Papu. As the title suggests, the article investigates the role profilin bears in relation to neurotoxic aggregation associated with Huntington's disease, instigated by interaction between Huntington N-terminal fragments, or as I'll be calling them later on, HTT-NTFs, and expanded polyglutamine, or polyQ, tracts. Such aggregates form in three phases, distinguished by sharp concentration thresholds that, if disrupted, would consequently disrupt aggregating mechanisms. Firstly, there is the soluble M phase, which is characterized by monomers and oligomers. There is the soluble S phase, which is dominated by 25 nanometer spheres. And lastly, there is the insoluble F phase, which is made up of long, linear fibrils. Profilin is an abundant cell-wide protein that has been shown to reduce such aggregation by binding to the C-terminal proline-rich region of HTT-NTFs. This article, through its experiments and analysis, indicates that favored binding of profilin in the M phase is, quote, enhanced through a combination of specific interactions between profilin and polyproline segments and auxiliary interactions between profilin and polyglutamine tracts, unquote. Such findings may have a beneficial effect on development of therapeutics that function to limit the number of aggregates formed by multiple aggregation-prone proteins. That has the basic gist of what the article is about. But more specifically, Figure 3 delves into the effects of profilin on a specific HTT-NTF, termed Q40C38. The Q40 is defined as the polyQ tract with length 40. This is a length chosen based upon synthesis and handling feasibility. And C38 is defined as a 38 residue C-terminal stretch, which acts as the region of the HTT-NTF that profilin will likely bind to. Both the polyQ tract of length n, or in this case 40, and proline-rich C38 are key characteristics of HTT-NTFs. With regard to Figure 3a, static right-angle light scattering measurements were performed as a function of Q40C38 concentration, or CS, in the presence of fixed concentrations of profilin, with the black indicating no presence of profilin, blue indicating 1 micromolar profilin, purple 5 micromolar, red 10 micromolar, and green 20 micromolar. Figure 3b is composed based upon the same experiment, but plots the concentration of Q40C38 as a function of the profilin concentration. Both graphs denote an increase in Q40C38 concentration, or CS, as the profilin concentration increases. The increase in CS suggests that profilin has the ability to destabilize the S phase. Now, what does this mean exactly? Well, to understand this, one must understand Figure 2b, which displays that an increase in CS indicates that profilin binds well to the M phase and destabilizes the S phase, and that a decrease indicates preferential binding to profilin to the S phase, so just the opposite. As one can see, CS increases, thus suggesting that profilin preferentially binds to the M phase. Based upon such thermodynamic linkage relations, the authors conclude that profilin must preferentially bind to the M, or F, phase to alter one phase boundary by ligand-induced changes. Further, they suggest that, in a closed system, one alteration to one phase boundary may necessarily lead to changes in all phase boundaries. As explained earlier, disruption of the phase boundaries in turn disrupts aggregating mechanisms. Now, this is a good thing, as such gained understanding of how profilin binds to specific phase aggregates would indeed help in discovering new relevant therapeutic approaches. So I suppose the main goal of the authors would be to discover the background needed to forge a therapeutic targeting HTT-NTFs that would mimic the effects of profilin, as the protein has been shown to decrease aggregation, which would consequently alleviate toxicity and be beneficial to those suffering from Huntington's disease. To reference any of the points discussed, a link to the article is provided here. Thank you.